So I want to show you how these relays work. So I have two models here. Okay, so this one is a 12 volt. Okay, and this one is rated as 24 volts. So you see this one has a schematic on it. Alright, so we have a coil between 2 and 5. That's between this and this pin. And then they have a contact. Basically it's just like a switch that you press with your finger. The only thing is this one is it's pressed by this coil here. So you energize this coil with, we'll see, normally the voltage rated on written here, so this one with 24 volts, and then it will move this contact from here to here, and C and O. And this one only has this pin, so normally the contact is from here to here, and when you energize this, the contact goes from here to here. Alright, and now I want to make some measurements to see at what voltage it will really trigger and how much current does this use, because I want to use one of these with a microcontroller. Alright, I will power this now. So I have 24 volts on the input here, and then we're gonna adjust the voltage using this screwdriver. It has a potentiometer here. Start with the measure of the resistance of the coil. Right, so this one is 420 ohms. This one is the 12 volt one, and this one the 24 one. Okay, this one is 1.6 kilo ohms. So that's 1600 ohms. And now I'm gonna use this one as on the continuity. So I will show you between this and this one is normally closed, I think, and this one is normally open. So you see it has continuity here and no continuity here until we put the current on this one. So when it will open, you will hear and see this one lighting up. And now I'm gonna use this one to measure the current. Okay, so we are on 200 milliamps DC current. All right, and now okay, so we have one here. Okay, so it triggers and we're gonna lower the voltage now. So this one is the 24 volts, and you see it already triggers at 13.6 volts. Okay, so now we're at 12.6. All right, so now we have this one is touching this contact, and this one is touching this one. You see we have a current of 7.7 milliamps. Now I'm gonna increase the current here until we trigger the coil. Alright, so now we're starting to increase. 7.7, 7.8, 0.9, 8, 8.5. Okay, so once it triggers, the magnetic force will keep it there, and you need to disconnect it. You see, when I lowered the current, it didn't stop. So I think it was around 8 milliamps, so we're 13.6. Okay, so around 8 milliamps it triggers. So 8 milliamps and a current of 13.6 volts. Now let's see if the 12 volts one does similar or not. We're gonna use the same type of setup. You see, it doesn't trigger. We need to lower this voltage because it will trigger for sure. Alright, so we start at 8.4 volts and see how it goes. So we need to lower it much more. Okay, so as you can see, we already have 12 milliamps. The other one was triggering at already 8 milliamps. And remember, this one, it says 12 volts. So around 17. Around, so we're 15.4 at 6.7 volts. 15.8, 16. Okay, so 17 is one. There. So it's 17 milliamps at 7.5 volts. What I wanted to show you as a comparison. So this one already, although it's rated at 24, it triggers from around half the voltage. It's more like 60%, I think, they're triggering. So this one has triggers at 13.6 and a current of 8 milliamps, and this one almost a double current. Okay, so this is how analog relays work. Hope you found this interesting. Like and subscribe if you want to see some more.